So good morning, and thanks for joining. Saturday, 10 a.m., and you made it. You're awesome. All right, so my name is Denis, and I work at OpenDNS. What OpenDNS does is DNS and security. So basically, we have a bunch of DNS resolvers that anybody can use for free. But if you give us some money, and you probably should, if you send a query for a domain name that we know is hosting some kind of malware, instead of returning a malicious IP address, we can return the IP of a sinkhole. In addition to that, we keep history of DNS records, and we use that to compute a bunch of reputation scores. OK, back to serious stuff. So what is a reputation? It's just some kind of number that you assign to something. And this is not enough to actually make a decision. It's just one of the many features that a classifier or a human or both are going to use to make a prediction and eventually a decision. Like, is this domain name malicious? Is this file some kind of malware? Should we block it? An IP address is expensive. I mean, even if it's just some cheap VPS, you still have to pay for it. And it's usually more expensive to buy an IP than a domain name. And in addition, buying a domain name anonymously is super easy. It's risk-free. It's not the same thing for an IP. And if only for this reason, the reputation of an IP is one of the most important features in security. This is just some random IP address hosting malware. As you can see, there is just a bunch of domain names. And actually, most of them are serving exactly the same content, the same ransomware. And in addition, we have a different domain name on the same IP serving a different kind of malware through malvertising. And this is very, very, very common. Suspicious IPs constantly have multiple domain names to serve exactly the same thing, and different kind of malware on the same IP as well. So one way to compute a reputation for an IP address, a super simple way, is just to count how many suspicious items we saw over how many items total we saw. And because this is not the same thing to have just one example, or maybe 100 examples, all of them being malicious, what we do usually is use a Bayesian average just by adding this constant c to the denominator. So this is a very simple and very classic way to just compute a reputation. A different way to do it is to check what clients that we know are infected by some kind of malware have in common, like the domain names that this set of clients have been looking up is likely to be a bit malicious. So a lot of models are based on this idea. Badness propagates, and goodness too. And this kind of model is super useful to actually extend existing lists. If you already know that on a given IP there is some malicious domains or malicious files or malicious websites, well, you can compute something. But what if you see something, you see a bunch of websites, but you don't know if they are good, bad? What can you do? Just assign some default score? Yeah, probably. So one thing you can do if you don't have anything is, well, rely on some known pattern, like DGAs. I don't know if you guys can read, but basically this is just a bunch of domain names, all mapping to exactly the same IP address, and they all look like gibberish. This is very common for botnet to use this kind of pattern. So we can just rely on that to assign a score. OK, we saw a lot of domain names looking like that, so maybe the IP is suspicious. But the thing is, this is something that we are seeing a lot with black hat SEO, like Chinese casinos and stuff like that, CDNs. Japanese mobile websites are using this kind of pattern a lot. So it's OK. I mean, hold on, dude. Don't move. Tilt your head to the left. OK, right. You look awesome. So this is cool. And this is really an interesting feature to use. But this is not so cool to actually compute the reputation of an IP. A different thing we can use is detect the fast flux pattern. So basically, fast flux is a domain name which is constantly jumping to a new IP address. Like every hour or every 5 minutes, you can see a new IP. So this is just a bunch of compromised hosts. And this is a great evasion technique. This guy is pretty cool because this is just one domain name, and in like 5 months, it's been using 564 different ASNs. This is totally nuts. So this is pretty easy to spot. And this is interesting, but the thing is, a lot of malware, even for CNCs, don't use this kind of system. It works. It's still a good indication that something might be malicious, but it's not good enough to actually compute the reputation of an IP, or not enough. We need something else. Like DGA-based CNCs, if the domain names are constantly changing, you don't need to change the IP. So I'm going to introduce a very, very, very simple reputation system. So malware, and in particular, everything related to exploit kits and CNCs, are constantly using a lot of domain names and subdomains and IPs as well, just because, well, I mean, between researchers and bad guys, it's a cat and mouse game, so the mouse has to keep running. If not, it's not fun. So once you have a domain name, you can have as many subdomains as you like. It's free. But in addition, what we frequently observe is that whenever some kind of domain name has been flagged by security products, 5 minutes later, you can see a new domain name, and the malware is shifting to this new domain name or a new set of domain names. So it can happen automatically or not. If you want, you can buy an exploit kit and run the rotation system yourself, or just buy it as part of the service. IP rotation happens as well, but slower. Hosting a command and control server on a compromised host would be a terrible idea, because you don't want some random guy to steal the credit card that you just stole. And in addition to that, you're not going to use some free hosting service as well, because they monitor bandwidth usage, and all your stuff is going to be taken down very quickly. So you want to actually buy some real hardware, or at least a good VPS, to host your CNC. So once again, the price of an IP address is higher than the price of a domain name, and subdomains are free. What is this matrix? Well, this is just for one IP address. So the actual matrix is on 3 dimensions, but just for one IP. So what do we have right here? So the columns are dates. So this is 6 days ago, 5 days ago, 4 days ago, till today, or till the last day for which we have a full days of log. And the rows are just domain names that we observed on this IP. And we just mark whenever we saw traffic on this IP for a given domain name and a given date. As you can see, on this IP, we have like 9 domain names. But the thing is, they are only being used for like 1 day or 2. And this is fairly common for malware. This is what a more stable IP address should look like. Still a lot of domain names, but more stable. There are less holes in this matrix. So what I'm going to show you guys right now is just some IPs, all of them being malicious, all of them hosting some CNC or some exploit kit, all of them being active for the past few days, each of them being totally different, hosting some different kind of malware, and we're going to see what they have in common. So this guy has a lot of names, DNS names, mapping to it. And what's interesting is that the domain names, actually the full names, are only being used once. Each client gets a different name. And of course, we are seeing a name only 1 day, and the next day, nothing. We see a different set of names mapping to the same set of IP. Different IP, different kind of malware. This time, we see more clients connecting to the same name. But once again, the next day, basically, the name is not used anymore. So we can see a lot of names on the same IP, but with a very short lifetime. In this case, we have less names. It's still significant, but still, the lifetime is 1 day. This guy, same thing, lot of names. And this one is pretty interesting because we can see a lot of queries to each name, quite a lot of names, and the lifetime is between 3 and 4 days. So that's pretty interesting. So a lot of names on a single IP is not a bad thing. I mean, load balancers or ad services or stuff like that are constantly using this scheme. But a lot of names active for just a very short period of time on a single IP, this is a bit weird. This is a bit suspicious. Not always, but it's usually pretty bad. So we can try a very, very simple way to compute a reputation score for a given IP. We just count how many domain names we observed on a given IP, and this times the number of days where no traffic was observed. Then we normalize and sort everything by reputation, and we take a look at the results. And remember, we don't know anything about what's good, what's bad. So this is what I did. I don't know if you can read, but this is just a list of IPs and the reputation. Once again, based on nothing, no prior knowledge. So let's take a look at the first one. So the first one, I don't know what it is, but it looks suspicious. It's a bunch of DGAs, so a bunch of domain names, registered very recently. We can see that there's been a spike of traffic. What you can see on the top is the traffic by day. So there's been a spike of traffic just for 1 day. A lot of domain names on the same IP, all looking the same, all suspicious. The next IP, oh, this is Tumblr. OK, looks like a false positive. Tumblr just moved a bunch of domains to an IP, a new IP. That's fine. The next one is a banking Trojan. And we can see a lot of traffic, no spike of traffic. It's pretty regular. But we can see a lot of domain names on the same IP. Once again, most of them have been registered just a couple days ago. So pretty cool, based on no prior knowledge. And if we keep looking at the list, we see more banking Trojans, Park domains, LiveJournal, OK, false positive. Some exploit kit, Microsoft CDN, because basically each client gets a different name. This is some kind of MD5 or something. So OK, false positive with the Microsoft CDN. Ransomware, Sinkhole, and FastFlux with Canadian pharmacies. So once again, it's not too bad based on nothing. So this is what we did before. We just marked whenever we saw traffic for a given domain and a given date and a given IP. Maybe we can improve the model just a little bit. Because what we observed quite frequently is just some noise, just some traffic, and suddenly a spike of traffic or some significant amount of traffic, and then it drops again, and then just some noise. So actually, we're only going to count when we see actual traffic, when we see more than 1/4 of the median number of queries per day. And when we do that, first, all the false positives that I reported before are gone. Well, they're not gone, but the score is closer to 0, which is great. And in addition to that, this new IP has a pretty low score, and this is hosting a set of active CryptoLocker domains. So once again, based on nothing, we discovered a bunch of interesting stuff. So this is a very, very simple IP reputation model. It can be improved a lot. Like you can assign different weights to different days. Like the current day can have a higher or lower weight. It's not a silver bullet. It's not going to spot everything. It's not going to give a bad reputation to everything. But it's generic enough to be interesting. It can spot some kind of malware. It's better than nothing. It's not a replacement for what you have now. This is just something you can use in addition to what you have now. And this is slide number 42. So I think this is a good number to stop at. So thank you. And now I guess it's time for questions.
Are you basing the lifetime of the actual label based on index domain responses?
No, this is only based on domain names that are actually resolving. We have different models for NX domains. So yeah, this is when domain names are actually resolving and starting to receive actual traffic. And actually what we are seeing quite frequently is a bunch of companies constantly tracking new domain names in order to maybe spot the content or maybe, I don't know, but as soon as some domain names has been registered, some companies are sending queries, and we are seeing these queries. So we have to remove all this noise before. So we actually only count, real traffic when something resolves.
Can you track authoritative name server changes in a similar way?
Actually, tracking name server changes is more interesting to track a specific scheme, which is the fast flux. We don't do it for this model. We only track actual A records. But yeah, for fast flux, this is definitely interesting to track name server changes. Yeah.
Have you looked at doing reputation based on authoritative name servers hosting malicious domains and the number of malicious domains that are being served by them?
Nope, not yet.
I missed it. Why is it called Dorothy?
Because there's no place like home. But if you have a better name for it, go ahead. Yeah.
So how would you recommend that an enterprise that wants to protect their clients use this type of reputation system? Is it something that you would bake into an existing product, or how would you actually use it?
So actually the product we have is computing a bunch of different scores. So you have this one, and a lot of them. So we have a reputation for ISNs, for subnets, and we have a bunch of different scores, and we have a generic classifier based on everything we have. So basically we can give you an API, and with this API you can both use it just to send queries like what are all the IP addresses that we saw for this domain name for the past 6 months. You can do that, and in addition you can get all the security features, and then it's up to you to actually use it to build your classifier. You can just use ours because, well, we output some label saying, hey, this is likely to be suspicious or not with the confidence. But most of the people are just retrieving all the features, and they already have something internally, like some kind of reputation for their customers. So it's just a bunch of additional features for their own classifier. Yeah.
Yeah, you mentioned how it wouldn't be smart to host a CNC server on a compromised machine. Do you actually see that?
Actually, no. I've never seen that. No. Exploit kits can be hosted on compromised machines, redirection services, proxies sometimes. But yeah, CNCs, no. No, people don't want to disclose their configuration, their software, and the data they store.
Well, they could be running a proxy on the compromised machine.
Yeah, proxy, that happens too, yeah.
It's kind of a naive daydream that I've had for months or years. If I were a bad guy and I wanted to start fresh tomorrow, I might avoid using DNS altogether. Is there anybody doing that? Or
so actually, what we saw recently is pretty cool. This is a kind of malware called PodMockup, and what it does is basically it's still using DNS, and so this is some kind of DGA, and then you get an IP address, but this is not the IP it's going to connect to. It's actually XORing with a key. So this is pretty interesting because you see IP addresses, but this is not what the malware is going to use. So this is an interesting scheme. But in addition, a lot of malware are using peer-to-peer, Tor. So yeah, a lot of evasion techniques. Even by using DNS, you can be pretty smart.
Yeah, how about IPv6? Do you see this?
I haven't seen any kind of malware using IPv6 yet.
you could ask for an IPv6 result and just pull out four bytes of it to be.
Oh yeah, right, yeah.
What the Google Chrome browsers look like when they look for the NS domain?
Google Chrome.
Yeah. It like randomizes.
Oh yeah. We're seeing a ton of them. Yeah. When you start Google Chrome, Chrome is trying to figure out if the DNS resolver you're using is actually intercepting NX domains and serving some kind of web page instead. And yeah, so every time you start Chrome, it just generates a random string. I think it's 10 characters or something like that. And we see a lot of non-existent queries, and this is super annoying, and root servers are constantly seeing that as well. But, well, it's okay. All right, thank you guys.